Good day and welcome again to my video of exercises number 7 entitled IP addressing exercises. For this activity, we will be needed one piece sheet of paper, pencil, and calculator. Calculator is for checking only. So let's proceed to procedure number 1, which is converting the following IP address to binary numbers. First one is 201.17.29.4. Letter B, 192.16.1.1. Letter C, 172.0.0.0. So let's start, and I will just establish my camera. There. So I will just write the bits. 1, 2, 8, 6, 4, 3, 2, 1, 6, 8, 4, 2, and 1. For this one, I will be using my cell phone as my calculator. So letter A, 128 minus 201, 73. So that is 1. 73 minus 64 is 9. 1 also. 9 minus 32, 0. 9 minus 16, 0. 9 minus 8, 1. 1 minus 4. 1 minus 4, 0. And 2 minus 1, 0. 1 minus 1, 1. Next is 17 minus 128, that is 0, 0, 0, 1, 0, 0, 0, 1, 21 minus 28, again that is 0, 0, 0, 1, 1, 1, 0, 1, and the last is 0, 0, 0, 0, 0, 1, 0, 0. So that's number 1. And letter B, I mean letter A. Letter B, 192, 168.1. So 192 minus 128, 64, that is 1. 64 minus 64, again it's 1. And 0, 0, 1, 1, 0, 1. 168 minus 128, 40, so that is 1 minus 64, that is 0, then 1, 0, 1, 1, 0, 0, 0. 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1. So letter C, 172.0.0.0, so that is 1, 0, 1, 0, 1, 1, 0, 1, and the rest is 0. So there. So now let us proceed to number 2. Convert this binary number to decimal. So what are we gonna do with this is add all bits with that has number ones. So for the first line, that is 128.64 plus 8 plus 4 plus 2 and plus 1. So second line is 4 plus 2 plus 1. Third line is 16 plus 8 plus 2, and for the last is 128 plus 32. So we will compute this. 64 128 plus 64 plus 8 plus 4 plus 2 plus 1 is 207. Then the second one is 7. Third is 16 plus 8 plus 2. That is 26. And the last is 128 plus 32. So that is 160. So the decimal form of these binary numbers are 207.7.26.160. So now let's proceed to number 3 procedure. We have here a network address which is 192.168.1.1 and a subnet mask of 255.255.255. Letter A question: what is the network address in binary? So the network address, we will convert it in binary. So let's proceed. 192 minus 128, that is 1. Then 0 0 0 0 0 0 1. Next is 1 1 1 0 1 1 1 1 0 0 0 0 0 0 0 1 0 0 0 0 0 0 1. So this is the binary number. Letter B is what is the subnet mask in binary? The subnet mask is 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1  and 0 0 0 0 0 0 0 0. So this is the subnet mask in binary. Letter C, what is the prefix length? Prefix length is, we will just count this up to this. So 1 2 3 4 5 6 7 8, and we will multiply 8 by 3 9, so that is 24. So the answer is 24. So last question is in the network address 192.168.1.1. In this network address, underline the network portion and encircle the host portion. So for this network address, the network portion is 192.168.1 and the host portion is 1. So that's it, and let us proceed to the questions. Right. Question number 1. Why do we need to convert the decimal value to binary numbers? So we need to convert the decimal value to binary numbers because most of the computers nowadays use binary numbers to operate. Computers represent numbers by using the lowest base number system used by us, which is 2. This is the binary number system. Computers use voltage, and since voltages changes often, no specific voltage is set for each number in the decimal system. For this reason, binary is measured as a two-state system like on or off. More than 100 rules would have been wired into the computer if we'd used the decimal number system for computers. But thanks to the binary system, only 4 rules are required by the computers for calculations. Last but not the least, the major reason computers use binary system is that the two-state system is the number system best suited to the optical and magnetic storage components of the computer. Number 2. Why all computing devices have an IP address? Is it possible to have a similar IP address among end devices? Explain your answer. Computing devices should never have the same IP addresses. Each device must have only one unique IP address. If they have the same IP address, the result will be confusing and may result to confusion. So it's not possible that there is only one IP address to all your computing devices. Like a physical home address for receiving mail, IP addresses act as a way to identify your computer on a network. Your router uses those IP addresses to direct network traffic to the right devices. If you have the same IP address as to your neighbor, it can result to a confusion. So, number 3 question, what is the importance of the subnet mask? Subnet masks designate which bits of an IP address represent the network portion and which bits represent the host portion. Default subnet masks are used with Class A, Class B, and Class C IP addresses. A subnet mask is a 32-bit number that masks an IP address and divides the IP address into network address and host address. Subnet mask is made by setting network bits to all ones and setting host bits to all zeros. Within a given network, 2 host addresses are reserved for special purpose and cannot be assigned to host. The 0 address is assigned a network address and 255 is assigned to a broadcast address and they cannot be assigned to host. What can you conclude from this activity? I therefore conclude that computing devices must have unique IP addresses. They should never have the same IP address because it can cause confusion to the users. IP address in computers sees it in binary numbers. So that's it, and thank you.